Acknowledgement. We would like to express our special thanks of gratitude to our lecturer, Sir Anas, who gave us the golden opportunity to do this wonderful project on the topic application of differentiation, which also helped us in doing a lot of research and we came to know about so many new things. We were really thankful. Secondly, we would also like to thank our parents and friends who helped us a lot in finalizing this project within the limited time frame.
Hello, my name is Nur Alahusnamiti Muhammad Sukri and my matric number is 2020858836.
Hi, my name is Nur Adriana Aisyah binti Azulin. My matric number is 2020843262.
My name is Iza Abida binti Harun. My matrix number is 2020896018.
My name is Nurul Nur Shakira binti Wahauddin. My matric number is 2004777982.
Introduction of differentiation. Differentiation is the process of deriving 5 prime of x from fx. We will look at this process in seconds. 5 prime of x is called the derived function of derivative of fx. The derived function represents the rate of change of the function and the gradient of the tangent to the graph of the function. Purpose of differentiation. Differentiation is to find out the rate of change of x with respect to y at a particular point, which is the gradient of the curve on a graph of y against of x.
Introduction of related rates. Related rates are rates of change associated with two or more related quantities that are changing over time. Rate of change is divided into 5, which is firstly dH over dt means rate of change height. dV over dt is rate of change of volume. dL over dt is rate of change of length. dr over dt is rate of change of radius. And last, dA over dt, which means rate of change of area.
Step: how to solve. First, sketch the diagram. Second, identify the rate of change known and to be found with respect to time. Third, find an equation relating two quantities. Fourth, differentiate step 3 both sides with respect to time. Fifth, substitute the known values obtained in step 2. Sixth, solve the remaining rate of change. Question statement 1. A spherical balloon is being inflated at the rate of 8 cm cubed per second. Determine the rate at which the radius of the balloon is changing when the radius is 10 cm. Let's solve the question together. Step 1. Sketch the diagram. The statement mentioned a spherical balloon means the shape is sphere. Step 2. Identify the rate of change known and to be found with respect to time. dV over dt equal 8 cm cubed per second. We use dV per dt as a rate of change of volume. Step 3. Find an equation relating to quantities and other information. As you can see, the balloon shape is sphere, so we need to use volume sphere formula. The formula is V equal 4 per 3 times pi times r cubed, which is r is 10 for radius, and the equation has given the information radius is 10 cm. Step 4. Differentiate step 3 both sides with respect to time. We use implicit differentiation. dV over dt equal 4 times pi times r square. dr per dt. Step 5. Substitute the known values obtained in step 2. dV per dt is 8 cm cubed per second. We write 8 equal 4 times pi times r square. R is 10 cm. Substitute 10 into r. dr per dt. step 6, which is the last step. Solve the remaining rate of change. 8 equal 4 times 10 square, 400, by dr per dt. dr per dt is what we want to find. Solve the remaining equation. 8 per 400 pi equal dr per dt. I move it to the right side so it's easier for you guys to see. dr per dt equal 1 per 50 pi cm per second. So the answer is 1 per 50 pi cm per second.
From the past statement has give the volume of water in the tank is decreasing at the rate of 20 meter cubic per minute. Before we start our mathematical calculation, we need to understand all of statements about volume and rate is going dv over dt. dv over dt in this equation is equal to negative 20 meter cubic per minute. And the question asks us to find rate of the water when water is 60 meter deep. dH over dt is equal to dH per dv multiply with dv per dt. Since this tank is cone, so we use cone volume formula for this equation. The formula is V equal to 1 over 3 pi r square h, and we need to know in this formula have two variables which is r and h. Since we need to find dH over dv, so we need to express r in terms of h. We are going to ratio r per h equal to 10 over 24 and express r in term h, and we will get 5 over 12h. We convert the v value into the formula and we will get 1 over 3 pi in bracket 5 per 12h square multiply h. After expanding the square, we get 1 over 3 pi bracket 25 over 144h square multiply h. And after we expand the h, we will get 25 over 432 pi h cubic. After that, we are going to apply differentiation knowledge to the differentiate volume, and we get dv over dh equal to 25 over 144 pi h square. Okay, now we want to find dH over dt that equal to in bracket 1 over 25 over 144 pi h square in bracket negative 20. Lastly, we are going to find dH over dt. Okay, first we need to apply dV over dt, which is negative 20 to and get dH over dt. And we will get dH over dt equal to negative 20 over 25 over 144 pi h square. Okay, firstly we substitute h equals to 16 in dH over dt equation. And we will get the answer is negative 0.1432 meter per minute.
From the past statement has gave the volume of water in the container is increasing at the rate of 20 cm cubic per second. Before we start our mathematical calculation, we need to understand all of statements about volume and rate is going dV over dt. dV over dt in this question is equal to 12 cm cubic per second. The question asks us to find rate of the water when the height of the water is increasing by h equal to 8. And now, we need to find dH over dt when h equal to 8. dH over dt is equal to dH over dV. Is multiplied with dV over dt. Next, the volume of water is given in the equation, so we need to expand the equation given. And then, insert the equation that have been expanded into the dH over dV, multiply with dV over dt. And then, insert the 3h plus 12 in the dH over dt, and then it becomes 1 over 3h plus 12. And then we need to multiply it with 12. So the answer is 12 over 3h plus 12. When h equals to 8, so dH over dt equals to 12 over 3 times 8 plus 12. After get the answer, which is 12 over 36, and then we simplify the 12 over 36, so the answer is 1 over 3 centimeter per second. So that's all from me. Thank you very much. Application of differentiation at real life are such as ladder falling, ice cube melting, and shadow.
For the conclusion, all of our questions that we solve with all objectives for this problem are accepted. Second, the solution that we use to find the answer in this problem are success. So, we can use this method to do other questions in our daily routine. That's all from me. Thank you.